right, so now we're going to talk about the conditional relative frequency. This is the percentage of people in specific categories, such as the rows or the columns. And to find this, what we will do is we will take a joint frequency and then divide it by a marginal frequency, as opposed to in the relative frequencies, we took the joint and divided it by the total number of people surveyed, and then we also took the marginal frequencies and divided it by the total number of people surveyed. So this is different. The conditional relative frequency, we may do 6 divided by 9, this 9 here, or maybe 6 divided by this total 11. We're not going to do 6 divided by 30 to get a conditional relative frequency because that is just a relative frequency. So there are row conditional relative frequencies and there are column conditional relative frequencies. We're going to start with the row conditional relative frequency. And so what this means is that I'm going to do my Dallas and car. I'm going to do that 6 divided by the total in that row. So this will be 6 divided by 11. And I'm going to write this as a percentage. So 6 divided by 11 times 100 gives us 54%. And that's rounded. So sorry, let me do my approximately equals 2 symbol. All right, for the train, I'm going to do now 3 divided by 11. 3 divided by 11 gives us approximately 27%. And then for the Dallas and walking, that's 2 out of 11, which comes out to be about 18%. Then with conditional relative frequencies, we don't necessarily do the total columns because we're only focused on the joint divided by the total in the rows. So the joint frequencies are just the middles. All right, so now we're going to work on the New York row. So I'm going to do 1 divided by the total in that row, which is 6. And that's about 17%. And then I'm going to do 3 divided by 6, which is 50% exactly. And then I have 2 out of 6, which is about 33%. So basically what this means is that 1 out of 6 people living in New York drive their car to work. So about 17% of the people that live in New York will drive their car to work. And 3 out of 6 people living in New York, about 50% of people living in New York ride the train. That's how we would read this. That's what that would mean. All right, now we're going to work on the Chicago row. So we do 2 out of 13. 2 divided by 13 comes out to be 15%. All right, and then 6 out of 13 comes out to be about 46%. And then 5 out of 13 comes out to be about 38%. Now, before we do the column conditional relative frequencies, I want to look at number 1, because it says to now look at the train column here. Sorry, this should say the row relative frequency table. And so how does this change your perspective compared to the total relative frequency table in the last lesson? So if we look at this one, we could not answer this question because we couldn't determine whether more people rode the train in Chicago compared to New York, because there weren't, these percentages reflect the percentages based off the total amount of people surveyed. And since there were more people surveyed in Chicago compared to New York, well, then we can't make that judgment of how many people realistically, or what the percentage of people realistically took the train in New York compared to Chicago. However, a conditional relative frequency, this actually provides a more accurate description of how many people, or the typical percentage of, how many people in New York actually ride the train and how many people in Chicago actually ride the train. And in fact, we can see that they're about the same, they're close, but actually there's more New Yorkers that rode the train compared to the number of people in Chicago that rode the train. And that's because we're doing the total amount of New Yorkers that rode the train out of all of the New Yorkers. So we're only comparing it between the amount of New Yorkers as compared to the total relative frequency table, where we were taking the number of New Yorkers out of the total number of people surveyed altogether. So how this changes our perspective is we have a clearer depiction of whether more Chicagoans or more New Yorkers ride the train. And the conditional relative frequencies tell us that there are more New Yorkers taking the train to work. All right, so now we're going to do the column relative frequencies. So this is out of all the people that took cars to work, 6 out of 9 people were from Dallas. So if I do 6 divided by 9, that comes out to be about 67 people were from Dallas that took the car to work. And out of all the people that rode their car to work, 1 out of 9 people were from New York. So that's about 11%. And 2 out of 9 people were from Chicago. So that's about 22%. Now, just like in the row frequency table, we're only focused on the joint frequencies, the joint cells when we're doing conditional frequencies. Out of all the people that took the train to work, 3 out of 12 were from Dallas. So that's 25%. 3 out of 12 people were from New York. So that's also 25%. And 6 out of 12 people were from Chicago. So that's 50%. Out of all the people that walked to work, 2 out of 9 were from Dallas. So that's 22%. 2 out of 9 were from New York, so that's another 22% of people. And 5 out of 9 were from Chicago. So that's 56%. Great. So these are the conditional relative frequencies. The conditional relative frequencies are actually the ones that we can look at the most and actually make a clear prediction or understanding of what is happening in the data. So moving on to number 2, it says, what is the conditional probability of New Yorkers commuting by train? So we are looking at, out of all the New Yorkers, so right here, how many commuted by train out of all of these New Yorkers? Well, 3 out of 6 New Yorkers commuted by train. That is 50%. Now, what is the conditional probability of all the walkers living in Chicago? So that's the column frequency, because we want, out of all the walkers, how many of them were Chicagoans? Well, that was 5 out of 9 people, so that was 56% of people that were walkers lived in Chicago. All right, number 4. Given that a person rides a train to work, so we want, out of all the train riders, what is the conditional probability that they also live in Dallas? So out of all the train riders, and you can use this too, out of all the train riders, how many lived in Dallas? 3 out of the 12 train riders lived in Dallas, which that's the column relative frequency. So that was 25%. And then, if a person lives in Dallas, what is the conditional probability that they drive a car? So out of all of the people that lived in Dallas, how many of them drove a car? So out of all the people that lived in Dallas, which there were 11 of them, 6 of those 11 drove the car. That's a row relative frequency. 6 out of 11 came out to be about 54%. Okay, so this question might seem a little tricky. Is it more likely that a commuter who walks to work lives in New York, or that a person lives in New York is a walker? This may seem like the same thing, but it is actually quite different. The first statement is saying that out of all the walkers, how many live in New York? So let's look at our table. Out of all the walkers, there were 9 walkers. How many lived in New York? That was 2. So 2 out of 9, notice how I'm working on this column. That's the column relative frequency. So 2 out of 9 was about 22%. So that was this part, about 22% for the first sentence. Now the second sentence is that a person who lives in New York, so out of all the people that live in New York, how many of them were walkers? So if we look at my table up here, out of all the people that live in New York, there were 6 of them. How many were walkers? There were 2. Notice how I'm moving throughout this row. That's the row relative frequency. So 2 out of 6 was 33%. So since this one had a higher percentage, it is more likely that a person who lives in New York is a walker. And that brings us to the end of this lesson. All right, you are now going to be moving on to the level 4 after you practice all of this.